All right, now that you've come back, let's talk a little bit more about our atom. We now know that the number of protons, or the atomic number, is the identity of an element that we can use to determine which element an atom is. But there's some more information we want to know about these atoms, and that is we want to talk about the mass of an atom. And before we talk about an actual measured mass, there's a very easy way that we can sort of discuss the mass of an atom without making a measurement. And I want to think about this way. Remember, we learned in the last class that protons' mass is basically the same as the neutron's mass. And that both of these are about 2,000 times more than the electron's mass. What this means is, if we're talking about the mass of the whole atom, that this electron mass doesn't really matter. If we're going to talk about the mass of an atom, we should really be focusing on this proton mass and this neutron mass. So the other number that we're going to talk about today, after we've talked about the atomic number, is going to be called the mass number. And again, this is the mass number. This is not the actual mass. We are not doing any measurements here. All we are saying is that the mass number is equal to the number of protons plus the number of neutrons. Again, the electron mass is so small, it doesn't matter. So we don't care. We're only going to add together the number of neutrons plus the number of protons to give us an idea of the mass of the atom. Again, this is not a measured number. This is only a count of protons plus neutrons. And I hope that you can understand then that the number of neutrons in an atom must be equal to the mass number minus the number of protons. And we know that the number of protons is called the atomic number. So the mass number minus the atomic number will tell me the number of neutrons. But why do we care? We said that the neutrons don't really do anything except that they change the mass of something. Well, the mass of something is going to be very important when we start measuring things later in the school year. So we will need to pay attention, because what I want to tell you is that not every atom of every element is always the same. Let me say that again. Not all atoms of an element are the same. Not all of them. There are different patterns. And we need to learn how to recognize the difference between these atoms. We're going to talk about this. We've already said that every atom of a single element has the same number of protons, and that is always true. So if we take a look at hydrogen, and we look at the periodic table, the atomic number is going to be equal to 1, which means we have 1 proton. Always. Always, always, always. And we said that the atom is neutral. So if we have 1 proton, then we must have 1 electron. Always. So every hydrogen atom has 1 proton and 1 electron. True. Always true. But the number of neutrons might change. Let me explain. I'm going to say there are sometimes or often more than 1 stable form of each element. And remember, we said that the neutrons are related to stability of the elements or of the atom. So we're going to learn about something new. And that something new is called an isotope. An isotope is exactly this. An isotope is, let me say this, isotopes are atoms of the same element with a different number of neutrons. And we said that the protons will never change. So if the number of neutrons changes, but the number of protons doesn't change, then that means they also have a different mass number. So we can use that mass number to help us understand or help us identify which isotope we're looking at. So again, isotopes are atoms of the same element with a different number of neutrons. So we need to figure out a way to use the mass number to identify an atom or to describe an atom without writing out all these long sentences. And there are going to be two different ways we're going to do that. We're going to write it out with symbols, or we're going to write it out with words. So using symbols, we're going to see something that looks like this. A, B, C. This A is the symbol of my element, or symbol for the element. This B is going to be my mass number. And this C is going to be my atomic number. For example, if we look at carbon, carbon's symbol is a C. The mass number for carbon will change, so we'll talk about that in a minute. The atomic number for carbon must be 6, because it's always 6. Carbon always has 6 protons. And I will tell you that the most common and most stable form of carbon also has 6 neutrons. So before I give you any more explanation, tell me, what is the mass number for carbon and how many electrons does carbon have? When you come back, we'll discuss.